Deep within the vast expanse of the Pacific Ocean, there is a rhythm. It is a heartbeat that dictates the fate of harvest in India, the ferocity of storms in California, and the price of bread in Europe. It is invisible to the naked eye from the surface, yet it is the single most powerful driver of natural climate variability on our planet. We stand on the precipice of understanding a colossal force, the interaction between the wind and the waves. This is the story of a cycle that balances the Earth's heat, a tale of two siblings, one warm, one cold, that shape our world. Welcome to the story of the ENSO Cycle. To understand this global phenomenon, we must first decipher its name, ENSO. It stands for the El Niño-Southern Oscillation. While it sounds complex, it is essentially a recurring climate pattern involving temperature changes in the central and eastern tropical Pacific Ocean. But it's not just about the water. Southern oscillation refers to the atmospheric changes that happen above that water. It's a dance between the ocean and the sky. This cycle is not static. It constantly shifts through three distinct phases: the neutral or normal phase, El Niño, the warm phase, and La Niña, the cool phase. Together, they create Earth's most influential weather pattern. Before we explore the extremes, we must understand the baseline, the neutral phase. Imagine a massive conveyor belt. Under normal conditions, powerful trade winds blow steadily from east to west across the tropical Pacific. These winds push the sun-warmed surface water towards Indonesia and Australia, creating a massive pool of heat in the west. Meanwhile, on the other side of the ocean, off the coast of South America, something magical happens. As the surface water is pushed away, cold, nutrient-rich water rises from the deep ocean to replace it, a process called upwelling. This setup creates the standard climate map we know. Heavy rain falls over the warm waters of Asia and Australia, while cool, dry air settles over the deserts of Peru and Chile. But sometimes the conveyor belt breaks. We call this disruption El Niño. The name has a poetic history. It is Spanish for the little boy, or more specifically, the Christ child. It was first named centuries ago by Peruvian fishermen who noticed a strange phenomenon. Usually around Christmas time, the cold, fish-filled waters would suddenly turn warm. What they were witnessing was the breakdown of the atmospheric engine. During an El Niño event, the mighty trade winds weaken, or in extreme cases, they actually reverse direction. This weakening is the trigger that disrupts the normal ocean atmosphere balance across the entire Pacific. When the winds die down, gravity takes over. The massive pile of warm water that was stacked up near Australia begins to flow back towards the east, towards South America. It acts like water sloshing back in a bathtub. The heat pool shifts from the western Pacific to the middle and eastern Pacific. This movement has a catastrophic effect on the coast of South America. It places a lid of warm water over the ocean, effectively shutting down the cold upwelling off the coast of Peru. This doesn't just change the temperature, it dramatically alters marine ecosystems and shifts weather patterns worldwide. The impact of this warm water arriving in the Americas is profound. In South America, the heat acts as fuel for storms. The arid deserts of Peru and Ecuador are suddenly battered by heavy rains and severe flooding. Landscapes that are dry for years can transform into temporary rivers and lakes. Further north, the effects ripple through the United States. During an El Niño winter, the jet stream shifts. We see warmer, drier winters in the northern U.S. and Midwest, while the southern tier, from California stretching all the way to Florida, faces wetter, cooler winters. It is a complete inversion of the typical weather map. While the Americas drown, the other side of the Pacific gasps for water. Because the warm water and the rain clouds that follow it have moved east, the rain effectively moves away from Asia and Australia. The consequences are dire. Australia and Indonesia often experience severe, prolonged droughts. The vegetation dries out, leading to a dramatically elevated risk of bushfires that can choke the skies with smoke. In India, the vital monsoon rains weaken. For a nation dependent on agriculture, a weak monsoon can be devastating for farming communities and food production across the subcontinent. Beneath the surface, an ecological tragedy unfolds. The breakdown of the upwelling off South America creates a marine life collapse. That deep, cold water is normally full of nutrients that feed the plankton. Without plankton, the anchovies die or migrate. Without fish, the seabirds starve. The food web shatters. Furthermore, across the tropical Pacific, the hotter ocean temperatures cause coral bleaching events. The heat stresses the coral, causing them to expel their life-giving algae. This threatens vital reef ecosystems that support a quarter of all marine life. But nature seeks balance. Often, after the heat of El Niño fades, the pendulum swings fiercely in the opposite direction. Enter La Niña, meaning the little girl in Spanish. She represents the cool phase of the cycle. If El Niño is the engine slowing down, La Niña is the engine going into overdrive. The key change here is that the trade winds do not just return to normal. They become stronger than normal. They blow with intense ferocity, supercharging the ocean circulation system across the Pacific Basin. Let's look at the mechanics of this cool phase. The supercharged trade winds push the warm surface water even further west towards Asia than usual. This creates an enormous, concentrated pool of heat near Indonesia and Australia. Meanwhile, in the east, the ocean is stripped of its warm top layer. A huge amount of cold water rises to the surface from the depths, creating a massive tongue of cold water extending from South America along the equator. The Pacific enters a state of deep chill. Just like her brother, La Niña reshapes the weather of the Americas, but in reverse. In North America, we often see colder, stormier winters in the north and northwest. Meanwhile, the south becomes warmer and drier, which can exacerbate drought conditions in places like Texas and the Southwest. But perhaps the most dangerous effect is found in the Atlantic. The atmospheric conditions created by La Niña reduce wind shear over the Atlantic Ocean. This usually leads to more hurricanes forming, creating an increased risk for coastal communities and islands from the Caribbean to the U.S. East Coast. On the other side of the world, the thirst is quenched, often too aggressively, because that warm water is piled up tightly against the coastlines of Asia and Australia. The evaporation rates skyrocket. This results in intense, heavy rains and catastrophic flooding across Australia, Indonesia, and Southeast Asia. In India, the effect is generally positive for the economy, but dangerous for the population. Monsoons tend to be stronger. While this brings essential rainfall for agriculture, it also brings the risks of devastating floods and landslides. You might be wondering, how do scientists decide which phase we are in? It comes down to a game of degrees. Scientists monitor the sea surface temperature, or SST, using a vast network of buoys and satellites. The magic number is 0.5 degrees Celsius. For an event to be classified as an El Niño, the water in the Central Pacific must be more than 0.5 degrees warmer than the average for several months. Conversely, the La Niña threshold is reached when that same water is more than 0.5 degrees cooler than average. It seems like a tiny fluctuation, but that half a degree represents a massive amount of energy shifting in the climate system. Unlike the changing of the seasons, the ENSO cycle does not run on a perfect schedule. It is irregular and somewhat chaotic. The cycle typically repeats every 2 to 7 years, but there is no perfectly predictable pattern. The duration varies too. An El Niño event is usually a sprint, lasting about 9 to 12 months before burning out. La Niña, however, is more of a marathon runner. She can persist much longer, sometimes lasting 1 to 3 years, double dipping through multiple winters, with neutral years scattered in between. The mechanism that connects the ocean temperature to your local weather forecast is the jet stream, a high-altitude river of air that steers storms. During El Niño, the heat in the Pacific pulls the Pacific jet stream southward. This acts like a funnel, bringing storms and much-needed rain directly into California and the southwestern United States. During La Niña, that heat is gone, and the jet stream is pushed northward. This directs the storm track towards Washington and Oregon, leaving the southwest high and dry. ENSO is not just a meteorological event, it is an economic one. Its impacts ripple through the global economy. In agriculture, crop failures due to drought, like wheat in Australia, or floods, like corn in the US, affect global food supplies and drive up prices. In the fishing industry, the collapse of fisheries in Peru during El Niño leads to dramatically elevated fish meal prices, which makes feeding livestock more expensive worldwide. Even the energy sector is affected. Mild winters during El Niño in northern regions mean less heating fuel is consumed, depressing energy markets. Because the stakes are so high, we watch the Pacific constantly. Organizations like NOAA, the National Oceanic and Atmospheric Administration, use sophisticated monitoring systems to track these changes. Using data from satellites and ocean buoys, scientists use advanced computer models to predict these events months in advance. These predictions are crucial early warnings. They give farmers time to choose drought-resistant crops and allow cities to prepare for potential floods or water shortages. As we look to the future, a new question arises. Is climate change affecting ENSO? This is currently a hot topic of research. As our background oceans get warmer, there is concern that it might load the dice. Research suggests that warmer oceans might make El Niño and La Niña events stronger or occur more frequently. We are already seeing the emergence of super El Niños, events of extreme intensity. These are becoming a growing concern as climate change amplifies the natural variability of the ENSO cycle, potentially making the weather extremes of the future even more volatile. It is easy to think of the tropical Pacific as a world away, but why does it matter to you? The temperature of the water thousands of miles away determines whether you will need a snow shovel or an umbrella this winter. It affects the price of the food in your basket, including coffee, bananas, and sugar. It explains the extreme weather news stories you see from around the world. ENSO is the link that connects global climate events to your local conditions and your daily life. In summary, El Niño and La Niña are two sides of the same coin. El Niño is the warm phase, where water moves east and winds weaken, bringing floods to the Americas and drought to Asia. La Niña is the cold phase, where cold water dominates the east and winds roar, bringing drought to the Americas and floods to Asia. Though they bring chaos, they are part of the natural ENSO cycle that balances Earth's heat distribution across the globe. They remind us that our planet is a single interconnected system, where a change in the wind on one side of the world can be felt on the other.